All right, so section 1.1 is a preview of calculus. The whole idea in this section is to kind of differentiate what things are before calculus and then what you're able to sort of broaden your mind to be able to do as you're encountering calculus, right? Why is there a need to do something in a different way, or what kinds of things can we now do that we couldn't do before? So this is actually, you don't need to copy this picture down, but this picture is on page 47 and 48, I believe, of your book. Does it say 47 and 48 in your notes?
Yeah.
Good. Okay, that was changed. It changed editions a few years back. So calculus is really the mathematics of change. So as you're thinking about, like, what is calculus? It's the mathematics of change. And I want to go through with you, at least briefly, quickly, some of the different things that you see in pre-calculus and then what you see as its sort of counterpart in calculus. So, for example, without calculus, you can find the value of that coordinate. So where it's got the C on the bottom and the point at the top, you can find the Y value at that point, right? That's a pre-calculus topic. With differential calculus, you can actually find the limit of what happens as you approach that value. So even if it's an open circle like you see there, it's kind of hard to see probably from where you are, but there's an open circle there. Even though there's not a value there, there's a value you're getting really close to, and that's called a limit. We'll be able to do that with calculus. On the second one, you can see we can find the slope of a line. You've been finding a slope of the line since middle school, junior high age. That's something that you've done a lot of. So the uniqueness of a line is that it's straight, right? And so we can find its slope. We can do the calculation pretty easily. But what we're actually able to do with calculus is find the slope of a curve. So something that's not straight, something that's continually changing, we can actually evaluate its slope, how steep it is at any point on the curve. With pre-calculus, you can find a secant line's slope. So a secant line, if you remember from probably geometry, that word secant, not in the sense of like trig secant, that's not what I'm talking about right now, but in the sense of a secant line is that it goes through 2 points on the curve and it connects them. It's a secant. And so that you can find the slope of a secant line using pre-calculus techniques. But with calculus techniques, we actually only need 1 point on the curve, and we can find the slope of that point, all right, at that particular point instead of between 2 points. Practically speaking, we can find the average rate of change for the speed of a car, right? So you can find out the distance you traveled, you can divide by the time, and you can find how fast your average speed was. With calculus, you can find the instantaneous speed, how fast you're going right now. My car tells me that, like in a number form. I don't even just have a dial, I have a number form. So that's called instantaneous speed, okay? So you can do that with calculus. In pre-calc, you can find the curvature of a circle. That's a very defined, specific type of an object. And then we move into something that's more arbitrary with calculus, and we can do it for any curve. It doesn't have to be specifically a circle, it can be any shape. With pre-calculus, we can find the height of the curve at x equals c. So you can find just a specific height. That's kind of like this first one over here. Like you can find the value there. But the comparison that it's making on this one is that with calculus, we can actually find the maximum height, where it actually peaks. Now with pre-calculus, you can do that with parabolas. There are methods for doing that, and you probably encountered them in an algebra course. But with calculus, we can do that for any curve. So we can do it for a cubic. We can do it for a sine curve. We can do it for things that are a combination of that. You can't do that with pre-calc. Three-dimensionally, something we won't encounter in this course, if you do end up taking a Calc 3 course, that's where you would encounter it the first time, is that you can find the tangent plane to a sphere. That's what you can do with pre-calculus, okay? So imagine having like a globe or a ball and putting a piece of paper against it where it just touches it at one point. That's a tangent plane to a sphere. But with calculus, we can do it to any surface. So this is sort of like the 3D analog of what we just talked about before. In pre-calculus, you can talk about the direction of motion along a line. Again, a very rigid object, very specific, lots of structure. But in calculus, we can do it along a curve. we can talk about area of shapes. You've done lots of areas, but they've been very definitive where you've got like lots of formulas sometimes, right? You can do areas of squares and rectangles and circles, right? Very specific area formulas. But with calculus, we can do it for arbitrary shapes. So you can see this image over here, arbitrary cubic kind of curve it looks like, and I can find that shaded area underneath where it's got this sort of funny edge along the top. We can find that area with calculus. That's what we will end with this semester. Chapter 4 is all about that. Work that's done by a constant force can be done in pre-calculus with a variable force in calculus. You can find the center of a rectangle with pre-calculus ideas. It's pretty basic kind of computation, midpoint formulas, things like that. You can actually find the center of a region, any arbitrary region that's not nice and symmetric with calculus. With pre-calculus, you can find the length of a segment, right? Again, straight pieces, right? But with calculus, we can do it for an arbitrary curve. It doesn't have to be a specific straight type of a curve. Okay, I think this is our last slide, yeah. Almost finished. Cylinder, right? Again, a very specific shape. You can find the volume of that. That's a Calc 2 topic, actually. Okay, so those of you who are taking Calc 2. The next part is, you can do it for an arbitrary shape in Calc 2, right? This shape on the right that's not a cylinder, almost looks like a vase or something like that would be, right? You can do it for that kind of a shape. You can find the mass of a solid of constant density, right? The density throughout's the same. But you can do it for an object with variable density when you're working in calculus. You can find the volume of a rectangular solid in pre-calc, but you can find it for any kind of a shape, a region under a surface in calculus. And then the last one also is in Calc 3, the sum of a finite number of terms. You can add 100 terms together with pre-calculus techniques and find how much the sum is. But when you move into calculus, we can do it for infinitely many terms, sometimes anyway, with calculus. Okay, so this actually provides a fabulous stopping point for us. When we come back next time, we're going to actually do two very specific problems where we're going to use pre-calculus to approximate what we're able to do with calculus for reals later on.